Hello world! Videos on this channel have been more code-oriented so far, combining theory and real-world examples to dive deeper. Today, I wanted to touch on a different type of topic than I usually do, and cover one non-code related subject, technical debt. Ward Cunningham coined the term back in 1992. Just because I always like a little bit of history around software engineering, I thought I'd mention a thing or two about Mr. Cunningham. He's the software engineer that developed the first wiki ever, and is one of the authors of the Manifesto for Agile Software Development. We also have to admire that he has said the epic phrase that the best way to get the right answer on the internet is not to ask a question, it's to post the wrong answer. Now, how cool is that? People will rush to correct you, but when it comes to simply helping you, well, that does not happen with the same passion. Nowadays, the largest portion of organizations that build any form of software follow some version of an agile methodology, such as Scrum or Kanban. Different buzzwords have become part of our daily vocabulary, such as dependency, uncertainty, impediment, daily backlog retro, just to name a few. And of course, technical debt is just another one. Well, if you work in such an organization, I can safely assume you've heard the term, and it probably was used to refer to bad code that exists in the code base. From experience, technical debt has become a synonym for bad code. But come to think of it, what does it actually mean? Why was it named like that? Is it always evil or a necessary evil even? How and why is it created? What can be done about it? Those are questions I want to address in this video. To begin with, technical debt can be defined as the cost of additional work caused by going with a quick and dirty solution rather than the most clean one. I want to make an analogy that will follow us for the rest of this video. Technical debt is a lot like financial debt. This is why it was named debt and not technical mistake or technical liking. In the financial world, debt is basically money that you have to pay back. Sometimes it's good to create such debt because it can act as a means to an end. For example, you borrow money to go to college. That creates debt because you have to pay that money back. But it's a calculated choice that will be repaid when you will be in a better state financially. Maybe you would not have been able to go to college if there hadn't been a student loan for you to take at that particular moment. And waiting until you find all that money without a loan could make you lose precious time to start your career. So you make a rational and calculated choice to sacrifice something today because it's more worth it now than it would be if done in the future. In the same way, technical debt, when calculated, can also be beneficial. You may have limited time to reach a deadline. Let's say you're creating an application for the World Cup, and the World Cup is happening right now. You need to ship that app as soon as possible, because if you ship it 2 weeks from now, the World Cup will be over. Now, you will take some shortcuts in the code, right? You will not bother creating modules, interfaces, extensibility points. You will just write code that can simply run as quick as possible, and then you will refactor after the fact, when there will be no pressure. This is also a calculated debt, but instead of money, you borrow time. However, both types of debt must be repaid, otherwise there are bad consequences. More on repaying the debt later. So, we have the first category of technical debt, the calculated debt. Debt that is deliberate and we consciously decide to get into. And as we saw from our example, it's not necessarily evil. It can be a good type of debt. It helps us reach a deadline, helps our company survive through a bumpy point in time, achieve the next release, or there will be a next release, a next funding, or a next milestone. It's a rational choice, and it is also tracked. You know exactly what you did, and what is there for you to repay in the future. Then we have the uncalculated debt, and this one is dangerous. Uncalculated financial debt can occur by maxing out your credit card on a shopping spree, or by poor judgment on a casino, or on a night out where you've had a bit too much to drink and spent the money irrationally. You will be in debt if you're not tracking your finances, and that debt is not a good one to get into because it's out of carelessness, and it is also probably untracked. It basically derives from mistakes and is nowhere documented for you to know that it even exists before it's too late. In the uncalculated tech debt, the equivalent to the above is hiring poor developers who simply do a bad job writing code. Or they could be developers that are good but do not care, or they lack accountability. But in my career, I have also experienced another type of uncalculated debt, and that is after merging with another product or company, or even getting a third party code or SDK that you now need to maintain yourself. This is also uncalculated debt. You did not plan for it, it was not up to the team, and this is also untracked. What should be the attitude towards tech debt? Well, again, like financial debt, this also depends on the character of the person or organization. Some people are totally against taking any kind of debt. They prefer to always use their money on a one-to-one matching with the costs of what they buy. Some other people can handle the risk of being in debt and learn to manage it and use it to their advantage. The same applies for the technical debt. There is no right answer here. You can choose to take only the absolute necessary one, or you can choose to use it more often and have a strategy in order to repay it. Because if you don't, it will accumulate. And speaking about repaying, I think it's time to touch on that topic now, as I promised a few minutes ago. This is me repaying my promised debt. I will keep the same analogy for that part of the video as well, about financial and technical debt, because it just works so well to help picturing those concepts, at least in my mind. If you do not pay your financial debt, what happens? Well, first of all, debt has some sort of interest that makes it more expensive as time goes by. So by not paying it in time, it makes it harder to pay later. And probably by not paying in time, we could get into more debt that will in turn make repaying all of it even harder. And finally, if we never pay the debt, we will eventually go bankrupt, or we can end up in jail. Going back to the technical debt now, the same applies. The more we keep code that was written in a rush inside our code base, the worse it gets, as it probably gets polluted by new features that will in turn need to be less clean to accommodate living next to bad code. The debt accumulates and becomes harder to pay, to track, to plan. If we never pay it, the code rots, which is the equivalent of going bankrupt. So we need to pay the technical debt as soon as it's created. I will emphasize that here. There is an exponential increase in complexity as time passes with a module of code that has been written badly. It's in your best interest to strive to fix it as soon as possible. Otherwise, you waste time, resources, and risk introducing new bugs. The more time passes from the moment of writing that code, the more the knowledge of the ins and outs of it fades. So there's another important reason why repaying the debt early is crucial. How can you repay the technical debt consistently? Well, it's all about proper tracking and proper planning. Every time there is deliberate technical debt being created, document it. This is either in a special file or it can be in a special Jira board. But the point is that this should end up in your backlog. It should then be planned as every other user story, keeping in mind the rest of the product prioritization. Remember, being transparent about debt and probably documenting it as it happens is the only surefire way to make sure it stays under control and your product stays in high quality. And one final important thing to discuss here. It's our jobs as software engineers to fight back the business people that will regularly request getting more technical debt in our code base. Remember, product or business people do not care or know about clean code, scalable code, or anything that we as craftsmen value so much. They have a feature and they want it shipped. Of course, they're going to put pressure on having it as soon as possible. But on our side, we have to put the opposite pressure on explaining why making a good investment today to properly develop a feature will massively make future features faster to implement. We need to explain that we should not take technical debt, for example, skipping unit tests, because that can put our quality at risk. And when you translate code language to business language, this is where you start seeing the proper reactions. Tell the product people that you need to follow the solid principles, no one bats an eye. Tell them that you will ship features 15% faster if you take one more day to finish a task, and then they will listen to you. It all depends on the point of view, so always take that into consideration, and remember, you are the ambassador of your code base. You should protect it as much as possible. And in your turn, you should try to understand that business and product always comes first, as this is what the end customer is receiving. This is what your company grows from. So let's recap. Technical debt is like financial debt. It's not evil when used in our advantage. Properly tracking it and planning to repay it is the way to move forward and avoid making our codebase a mess down the line. Avoid unnecessary debt and be absolutely sure when and why you choose to take it. Finally, remember to communicate and be transparent about the existence of debt and its consequences to both technical and non-technical people alike, each in the language they understand. Thank you very much for watching, and let me know if I should make more of these types of videos in my personal links in the description right below the like button. I'll see you around.